Automating tasks with SQL Server Agent. All right, automation. Automation is a wonderful thing, and it's the name of the game in this industry, really. Not only does automation help us save time and help us save money, but it makes bosses happy. And if you don't believe me there, try it out. Find your boss, find a common task that your boss does, and automate it for them. Not only will you get a big smile on their face, but you'll score brownie points for that next raise. So that's what we're going to be covering in this video, a big look at automation. And we'll first take a big look at an introduction to automation. I'll get you familiar with the SQL Server Agent service, which is really the heart of automation, and all the components underneath the SQL Server Agent service and how they interact with one another to make automation possible. I'm also going to introduce you to a brand new feature in SQL Server 2005, which is database mail. And yes, database mail was around in the past, but it's been completely rebuilt from the ground up, and it's not the same as it used to be. In fact, it's a billion times better. If you've used database mail in previous versions of SQL Server, you'll know that it was a pain in the tushy. That pain in the tushy has gone away, and it's very easy to use database mail now, so we'll get you familiar with that. We'll then talk about how to configure these things. We'll configure the SQL Server Agent service, and we'll configure database mail. Once we're all configured, we'll move in and learn about how to create these automation components. We'll talk about and learn about how to create operators. Operators are, of course, individuals who will receive notifications if things either succeed or fail. We'll then move in and learn how to create alerts. Alerts are just events that happen. So if a certain event happens, we'll raise an alert. An alert will then either notify an operator or kick off a job. And a job is really the heart of automation. This is where we're going to create a job to automate a specific task or tasks. And of course, if a job fails or succeeds, we may want to notify an operator. So all three of these components really interact with one another to make automation happen. And we're going to learn about how they interact with each other right now. So let's go ahead and jump on into an introduction to automation here and get familiar with how all of these components work. So starting with jobs here, as I mentioned, jobs is really the main component that we're going to be working with when we want to automate a specific task. What we do is we create a job. Jobs contain what are called job steps, and these job steps are just specific actions that can be performed. So, and they run sequentially inside of the job, and once the last action or job step is completed, the job will then report success or fail. And each one of these steps also reports success or fail. But basically, what each one of these steps are, it can be anything. You can define one step as a transact SQL statement. You can define another step as a VB script or a J script. You can define another step as an operating system command. So we'll go through all the different types of actions that can be performed. But really, they cover everything. And we can really do pretty much anything you can think of using these job steps. And how this works here, I'm kind of trying to represent that this is SQL Server Agent here. And then here are all the components underneath it. Jobs can either run locally on the local server, or they can also run on multiple remote servers. So we'll talk about that, and I'll show you how to do that when we get there, which is just basically setting up what's called a master server and then specifying a bunch of target servers where this job can be copied to and ran from. So pretty cool stuff there. We also have schedules, and a schedule, in the past, schedules weren't really their own object. In SQL Server 2005, they are their own object. So now we can create one schedule, which is just, of course, what times this job can run, and then we can attach this one schedule to multiple jobs. So just saving us a step of creating the same thing twice. Kind of nice of Microsoft to help us automate our own jobs. Pretty cool. And that's that with schedule. We can also create alerts, and alerts are really nice. What these do, an alert is, again, just an automatic response to a specific event. We can create alerts based on three different categories of events. We can create an alert based on a SQL Server error. So if a specific error number was thrown in SQL Server, we can say if that error number is ever raised in SQL Server, kick off this alert. We can also create alerts based on SQL Server performance conditions. So those performance counters we looked at inside of our monitoring SQL Server 2005 video, we can use those performance counters and say if this counter ever rises above or equals a specific value, then kick off this alert. And you can also create alerts based on WMI events on the local machine that SQL Server Agent is running on. WMI is Windows Management Instrumentation events that may happen on the local computer. Now, what happens when an alert gets fired is one of two things. Either an alert can notify an operator, or it can kick off a job. And I'll show you how to do this here. We're going to actually create an alert based on a performance condition, and then we'll do one of two things. We'll either notify an operator, or we'll kick off a job. And if the job fails, then we can notify an operator. And that leads us right into our operators. An operator, again, just an individual to notify. Inside of an operator, we'll define basically the name of the operator, an email address for the operator, a net send address for the operator, even a pager address for the operator, and then we can specify all the times that this operator is available. And again, an operator is just that. It's just a contact. So if a job fails, we can notify an operator. We can use an alert. If an alert kicks off, we can notify an operator, things like that. So these are all the major components that make up SQL Server Agent and also make automation possible. We're going to learn how to actually create each one of these, and we'll also make them all interact with one another again to make automation happen. Another thing we're going to want to do if we want to send email notifications to our operators and just in general use email in SQL Server, we're going to set up database mail. And database mail I'm really excited about for this version of SQL Server, mainly because it's easy to use. And I say that with excitement because if you've used database mail in the past, you'll know that we had to jump through hoops to get it set up. And it was mainly because of this guy right here, Mappy, the messaging application programming interface. This protocol actually had a few dependencies outside of SQL Server, and it was just never an easy thing to set up. We had to jump through hoops. Basically, you needed a Mappy compliant client in order to do so, and that would come in the form of either an Exchange server somewhere on your network or Outlook installed locally on the computer that SQL Server was running on. So, never an easy thing to set up. Now, however, database mail has been completely rebuilt from the ground up. Microsoft heard the community. We wanted database mail to be an easy thing. So they rebuilt it, restructured it, and it's now based on SMTP. The simple mail transfer protocol, as the name implies, we just simply need an SMTP server somewhere that we can relay these messages through. No client that depends on SMTP or anything like that. So very simple to set up. And Microsoft didn't just go ahead and give us an SMTP-enabled database mail system inside a SQL Server agent, but they built a very, very robust enterprise-level solution for database mail inside a SQL Server. And what I mean by that is it's all of these things. It's robust, it's reliable, it's stable, secure, it's even scalable, and most importantly here, it's easy to use. So it's all of these things because, number one, we have process isolation. What this basically means is database mail runs in its own process window. So it's outside of SQL Server. If database mail ever goes down, guess what? SQL Server is unaffected. If database mail, if you're sending a lot of mail through, it uses a queued system underneath the hood, so it's kind of like having a little mini Exchange server built right into SQL Server Agent. So it's very robust. It can handle pretty much anything. We also have failover accounts, and what this basically means is once we set up a profile, we set up a bunch of SMTP accounts that it can relay these emails through. And we can set up as many accounts as we want and then set priority on them. So basically what this means is database mail will try one account. If that account, if it can't access that account for whatever reason, maybe it's offline, it'll try another one. And it'll keep going until it can send these mails out. So the point here is database mail, it's easy to use and it's based on SMTP. So we'll get that configured here right off the bat and we'll use it and test it. We'll send our operators when things go wrong, when jobs fail or succeed, and when alerts get risen. All right, the next thing we're going to do here is configure SQL Server Agent, and then we're going to configure our database mail. Once we get done with configuring things, we'll take a look at how to create each one of these objects inside a SQL Server Agent. So we need to configure SQL Server Agent. There's a few ways we can do this. The first way you can do it, and the recommended way here, is using the SQL Server Configuration Manager. So to get there, we're going to go down to Start, drag on up to Programs, and on over to SQL Server 2005, down to our Configuration Tools, and into our Configuration Manager. So what this is going to do here, the Configuration Manager is meant for configuring services on the local machine. So we will actually want to configure our SQL Nugget machine, and we're on our VB Nugget machine here. So the other way to configure this, if you want to configure them remotely, is to use the Services console. So to get to there, and I'm going to jump back in here in a second to show you the differences, but to get to there, we want to go to Start, up to Settings, over to Control Panel. Once you're in your Control Panel, we want to go into our Administrative Tools node here. And once we're in there, we're going to scroll down until you see Services. So you can still manage all of these SQL Server services inside of the Services applet here. The difference is, of course, this is just kind of streamlined for just the SQL Server services, where services is all the services on the local machine. The nice thing with this, though, is that we can connect to other remote machines. So we're going to right-click on our node, Services node here, choose Connect to another computer, and type in SQL Nugget so we can configure the services over on our SQL Nugget machine remotely here from our local VB Nugget machine. You can see once we scroll down in here, down to the SQL, the S's, you'll start seeing SQL stuff. And look at this. They're named the same exact way as the configuration manager here. It's just that we're on our remote machine in the services console. Here we go. Here's SQL Server Agent. There's our dev instance. Here's our production instance. We're actually going to be working on our production instance. So if you double click on this guy, it'll open it up. Here's the service name, the display name. gives us the description, where the executable is. If you're going to be using SQL Server Agent often, you're automating jobs daily, you have alerts set up, you're definitely going to want to set this to automatic. And then you're also, if you're using jobs that access files remotely on the network, on a network share somewhere, or anything like that, you're going to want to make sure that the SQL Server Agent account is running under a domain account with the appropriate privileges. So I'm running it under the admin account for our CBC Nuggets domain, which is pretty much a domain admin, access to everything. So we know we're okay. The differences here between configuring it in your services and configuring it inside a configuration manager is we take a look here. Let's take a look at our local VB SQL 2005 test instance. If you double click on this, you'll see it's pretty much the same thing here. Here's our security. Here's the actual service. You can see the start mode. Everything's pretty much the same. You just have a little more properties here. And also the advanced tab is where the differences lie. You can create a error. You can pretty much have it dump an error log out to a file here. And this is why the services node can't handle it and why you can't connect remotely, because you're configuring paths on the local machine here. So pretty much the only difference. Other than that, you can use services again to manage SQL Server Agent service remotely, or the configuration manager manages these services locally. So once we get the actual SQL Server Agent services configured here, the next thing we're going to want to do is head on into SQL Server Management Studio and configure the agent itself. So if we go down to Start and up to Programs, on over to SQL Server 2005 and right down to the Management Studio here, we'll fire this guy up. We'll go ahead and say, yeah, sure, connect us to our SQL 2005 production instance here. At the very bottom, you're going to see SQL Server Agent. So here's the service once again, only this time, if you right-click on it and choose Properties, we have a lot more configurable items that we can manage at the SQL Server level. So the first note is just general configuration information regarding the agent service. The first one, it just shows us what state the service is currently running in, running, stopped, or paused. We also have an option here to say if SQL Server stops unexpectedly, have SQL Server Agent attempt to restart it. So this is the core SQL Server service here. And then also the flip side of that is if SQL Server Agent stops unexpectedly, have the SQL Server service attempt to restart it. And then we have error logging information here. We can just specify a file that'll pipe any sort of agent error that occurs in the SQL Server service. It'll pipe it into this file. Also, if you want super detailed error messages, you can choose this to include execution trace messages. Keep in mind this will add overhead, though, to the SQL Server Agent service, so only use this if you're troubleshooting a specific error. And also, if you want these errors not only to get piped into this file, but also to a computer, an individual on a computer, you can type in the NetSend recipient here that'll receive those errors as they get piped into this file. And we'll talk about NetSend and how that works once we get into setting up operators, because we'll do that. We'll actually NetSend an operator when an alert occurs. On the Advanced tab here, what we can do is a few things. You can set up SQL Server event forwarding, and this is good. This is mainly for the alert system. You can say you have 3 SQL servers in your network and you only want one SQL server to handle the events. What you can do is set up event forwarding on this server to forward all those events to another server, so the events will get raised on that server. And you can say unhandled events or all events, and you can also choose what event, if it's above a certain severity level, to only forward them. We'll talk more about events again when we get into the alert system. Also here, you can set up the idle CPU condition, and this is really meant for jobs, because when we set up a schedule on a job, we can say only run this job when the CPU becomes idle. And this is where we'll define that idle CPU. When is a CPU idle? Is it when the CPU average falls below 10% and remains there for 600 seconds? So you can kind of define that here. So that's pretty much it for the standard configuration properties of SQL Server Agent here inside of SQL Server on the General and the Advanced tab. We'll talk about these other tabs when we get there. Actually, we'll be back into the Alert System tab here shortly, because that's where we enable database mail. But before we can enable database mail, we have to configure it. So to do that, we have to go into the Management folder here. And once in the Management folder, you're going to see a Database Mail node. This is where we're going to configure everything Database Mail. So to do this, just right-click on Database Mail and choose Configure Database Mail. And this is going to pop open a handy little wizard, and this wizard, very easy to use. We're going to be in here for no matter if you're creating a new database mail account or profile, if you're going to manage security, pretty much everything when it comes to configuring database mail will be done through this wizard, and it's actually a really easy wizard to use. The first time you run it, though, you're going to want to go ahead and set up database mail. We can also use this wizard, though, to manage our mail accounts and profiles and to change system parameters, and also to manage profile security. But you can't do that unless you have profiles set up, and we don't, since it's the first time running it. So we're going to go ahead and choose Next here. The first thing it's going to have us do is create a profile. So the profile here is really the top level object when it comes to database mail, because we create a profile and then we add SMTP accounts underneath this profile, and how those accounts are added in here is really how their priority is. So whatever position they are in this list is going to be the priority, and that matters because that's where failover account comes into play, and that's really what it's telling you here, is this is where a failover priority is set just based on the order of this list. But the first thing we need to do here is get a profile name. So let's call this SQL Agent Mail, because this is where all of our SQL Server Agent related tests are going to use to send mail. And we'll give it the description here, SQL Server Agent Mail Profile. There we go. And again, now we just need to add some accounts in here. So let's go ahead and add an account. We'll click the Add button. We'll give this account name mail.vbnugget. And what we're going to do here is, I have on our local VBNugget machine here, I have IIS set up, Internet Information Services, and by default, IIS is SMTP enabled. So we're going to use VBNugget as a relay server to pipe that mail through from our SQL Nugget machine. We'll give it the description here. How about VBNugget mail relay? The next thing we need to do is give an email address. Again, this is how whatever users are going to see this email is coming from. So let's name this SQL Agent at cbtnuggets.com. The display name is going to be, how about SQL Server Agent? This is where it's coming from. And then I like to put in the actual instance it's coming from in case we have multiple instances set up to use database mail. We'll know what instance it came from. So we'll call this sql2005 prod. So we're setting it up for. No need for a reply mail at this point. You can put a reply mail in case someone wants to reply to these emails, then they'll have a valid email address, since this isn't a valid email address up here. And the server name is, of course, vbnugget.cbtnuggets.com. On port 25, that's the standard SMTP port. We don't require SSL in this case. We don't need any authentication. And that's it. We click OK. We have an account set up. So at this point, our profile is pretty much set up. You can add more SMTP accounts if you want to take advantage of the failover features of database mail. But we're all set here. Our profile is set up. The next thing we need to do is click on Next and deal with security. So security is pretty simple too. It's either a public profile or a private profile. If you make it a public profile, this means that any user that has access to the MSDB database, which is a system database, and really that's what SQL Agent relies on. It stores everything, all information is about jobs, tasks, you name it. SQL Agent is really reliant on the MSDB database. Also, if they are a member of the database mail users role, and they must be a member of that role in the MSDB database to use this. So that's what makes a public profile accessible to those users. We just check it here. You can also make it private, in which case you would have to choose a user. And again, these are users, the only users in this list will show up that have access to the MSDB database. But again, you can make it so only a specific user can access this profile, and that would be a private profile. But we're going to leave this as public here and then choose Next. The final screen here is all about choosing and configuring your system parameters for this profile. Basically what this means is just simple properties here. Account retry attempts, how many times is it going to retry a specific account? Do you want to put a delay on it? Maximum file size in bytes. What attachments do you not want allowed to send in those emails? The maximum or minimum lifetime in seconds of the executable of database mailing itself. This is the actual process itself. And also the logging level. And you can either do extended or verbose. And again, verbose is kind of like we looked at the SQL Server Agent trace execution option. Same thing here. If you're troubleshooting an account, use verbose because you'll get very detailed error messages, but it does add overhead to the system, so only use it when you're troubleshooting. We'll leave it at extended here. But once you set up your system parameters, your accounts, and your profiles, we're all set to go. We choose Next, gives us our summary here. We choose Finish, and boom. It's going to go ahead and set up database mail here. Sets it up pretty quick in a jiffy. So we'll click on Close, and the next thing we want to do is test it out. To test it out is a breeze. We just right-click on database mail and choose Send Test Email. From this point, we just choose a profile. Obviously, we only have one in here. Choose who we're going to send this to, and I'm going to send it to, I set up a Gmail account called garth.sqladmin@gmail.com. We'll leave the subject here, database mail test, and the body. We'll click Send Test Email. It's going to fire off that process. It's going to tell us that it's been queued for processing. And again, it's a queued system. It's a very, very reliable system. So if it can't send it for now, for whatever reason, it'll sit in the queue until it can send it. We'll choose OK here. And I'm going to actually go into Start, up to Programs, and I configured an account here in Outlook Express to tap into that Gmail account via POP3 protocol and grab it. And check it out. It already did a send. If we go into our inbox here, there it is. It's from our SQL Server Agent, SQL Nugget, SQL 2005 prod instance to me. And there it is. Who it's from, the subject, and everything's all set. So it sent that really quick. And boom, database mail is configured, up, running, and tested. Also, if you're having problems configuring it, say we didn't get that email for whatever reason, if you right-click on it and choose View Database Mail Log, this is going to fire up something that should look familiar. It's basically all of our logs here with database mail checked, and boom, look at this. It shows that the database mail process was started. If you have any errors, they will be in here. They'll give you very detailed error messages and tell us what went wrong. So that's how you can monitor it, configure, and test database mail. Now, there's one more thing you're going to want to do to actually be able to use database mail, because it is not enabled by default for SQL Server Agent. But to do that, we just go back into that properties here by right-clicking on SQL Server Agent. And this time, go to the Alert System tab here. Once we're in there, we need to check Enable Mail Profile. And then you can see here, if you drop down the mail system, the SQL Mail, this is the old version. This is using MAPI here. This is the old SQL Mail. They only provided it for backwards compatibility. Microsoft does say right in their documentation, though, to get away from this if you can, because it will not be supported in future versions of SQL Server. So we're going to go ahead and choose our database mail, choose our only profile here, and then you can do some other things here. You can pre-format your page, your emails. You can see this text box, just because we're on a low resolution, this is actually a text box. You can predefine a body in here. And then you can also set up fail-safe operators. And also, we'll come back to this token replacement when we talk about alerts and jobs. But that's pretty much it. I just wanted to show you here how to enable database mail for SQL Server Agent. Once you do that, we'll click OK, and we're ready to rock. All right, so now that we're configured here, we have SQL Server Agent configured, we have database mail configured. Now it's time to get to the core automation components, and we're going to start off with operators here. We need to create individuals that are going to receive these notifications if maybe a job either succeeds or fails. We'll also need to notify an operator if an alert takes place. So to create an operator, very simply, you just right-click on the operator folder here, choose new operator. We'll give it a name here. How about SQL admin? Of course, the SQL admin is going to be the first one that should be receiving all these notifications. And I'll, of course, play the SQL admin here. So I'll get my email address in here, cart.sqladmin@gmail.com. Our net send address is going to be our local machine that we're sitting on here, VB Nugget. And a net sending, if you're not familiar with the net send, let me give you a quick demo of it. I'm going to go to Start Run, fire up the command line here, and type in net send, computer name, which is going to be ourself here, and then the message, hello. Click enter, and boom. A net send is just simply a message that goes across the network and pops up on whatever machine you're sending it to as a dialog box right in front of them on screen there as it happens real time. Boom, hello. But in order for net send to work, it relies purely on the messenger service. So let me just show you where the messenger service sits here. I'm gonna take the shortcut as I usually do here. Start run, we'll type in services.msc to fire open our services applet. And down in here, you're gonna see the messenger service. So you need to have the messenger service here enabled and started in order to receive net sends. Otherwise, that won't work. And just to let you know, the messenger service is disabled by default. Some of the latest, I think Windows 2000, one of the later security patches, and then of course Windows 2003, there's no way it's enabled. It's always disabled by default since then. So if you're going to use this, you need to have messenger service enabled on both the machine sending it and the machine receiving it. So just a little tidbit there. But if you're going to use net sends, you have to do that. We are going to use them just to show you how it works here. So I'll type in our VB Nugget machine as the net send address. That's the individual or the machine that is going to be receiving these net sends. And then you can also type in a pager email name and then set up a schedule for when this pager will be available if you need to contact it via pager. Also, we have a notifications node here. This will just show what notifications this user or operator is currently receiving and jobs if there's any enabled here. We'll come back to the screen once we get an alert sent to this operator when it happens. Same with jobs once we set up a job, and again, this operator will be notified when that job either succeeds or fails. So we'll come back in there and show you that. But again, very simple to set up an operator here. Once we're done, we click OK, and now when we expand the node, boom, we have our SQL admin operator all set up. So now that we have an operator set up, enabled to receive notifications, let's go ahead and create an alert here. And again, an alert is based on, an alert is going to get kicked off if a certain event or condition occurs. And we define what that event or condition is. Let's say, for instance, we're having problems with the transaction log. The transaction log is filling up every now and then, and we want to know if the transaction log gets greater than 90% full so we can do something about it before it becomes 100% full, because at that point, our users would get locked out of the database, and of course, that would be really, really bad. So create an alert, very simple to do. We just right-click on alerts here, choose New Alert, First thing we do is give it a name. Let's call this the translog full alert. And then we choose next the type of alert. So SQL Server alert, SQL Server performance condition alert, or a WMI event alert. Again, Windows Management Instrumentation there. The SQL Server alert, very simple, you just choose a database. If you're going to base this on a specific error number or a severity level, going from least severe to most severe, all down here at the fatal level, you can create alerts based on those. As I mentioned when we were talking about our slides there, you can create an alert. You can create your own error numbers and then raise those error numbers from your stored procedures or your Transact SQL code, and then you can trap for your own custom error numbers. So that's what I mean by you can create your own custom alerts based on custom error numbers in your own code. So that's kind of nice to have the flexibility to do that. We're going to keep it simple though here and create one based on a SQL Server performance condition alert. We're going to drop down our object here. Databases is the object we're looking for. %log used is the counter we're looking for. We're going to toss this against the AdventureWorks database. We'll say this is our production database that's been having the problems with the transaction log. And then we're going to say alert if this counter, let's call it rises above 90%. Simple as that, right? And that's it. So now we have our alert created here. You can also choose the response. The response can be either execute a job, and we're going to create a job here shortly that'll take care of this, but we don't have that created yet, so we'll leave that unchecked. If this alert were to happen, we're going to notify this operator. How about from email and NetSend, just because it is a critical condition. So if they're not, for whatever reason, have their email client open and they're at their computer, they'll get a NetSend. You can also do pager as well if you set that up. You can also see you can view your operator here if you want to view the details of your operator, or you can create a new operator right inside of here. Pretty nice. And finally here we have some options. We can choose to include the actual error text inside of the email and the NetSend, which we will do. And then you can add additional information in here. You can also delay between the responses themselves, minutes or seconds, minutes and seconds. And that's it. So now, once we click OK, it's going to go ahead, create that alert. Now if we expand it, there's our alert, transaction log full. All right, so at this point, if our transaction log fills up past 90%, our alert will get kicked off and our operator would immediately get notified, but our operator would have to break away from whatever they're doing to immediately manually intervene with this transaction log to get it back to a manageable size so our users can, of course, use the database efficiently and we don't have to worry about the transaction log. But wouldn't it be nicer here is if the alert kicked off, rather than notify an operator right away, kick off a job that would attempt to shrink all of these files down back to a manageable size. And then if the job fails, we'll notify the operator for manual intervention. So adding another layer in here to protect our operators so they can get other things done rather than fight all of these alerts all day long. So to create a job to do that, very simple. We just right click on our job folder here, choose new job. We're going to give this job the name shrink database. You can see you can give it an owner here. We'll leave it at the default. You can also give it a category. And it's nice to categorize these things just simply because if you have 100 jobs, when you go and you try to run a job manually, you can sort them by categories so you can find your job easier. So I like to do that. You can also create your own categories. I'll show you where to do that here shortly. You can give it a description. We'll give this the description. How about shrink database and associated files. There we go. Next thing we do is define our action steps. So these are the actual steps that are going to go down here sequentially when this job is ran. To create a job step, we just choose new. That'll fire open our job step dialog box here. First thing we do is give it a name. So we're going to call this dbcc shrink database because that's the command we're going to run. And then we define what type of step this is. Of course, this is going to be a Transact SQL step, but just to show you here, you can define, as I mentioned earlier, you can define steps that are actual scripts, VB script or JavaScripts. We can define operating system commands here, run operating system commands. And then a couple other things with replication, analysis services. You can also run a integration services package. We're going to keep this as a Transact SQL script, probably one of the more common ones. We next define what database this Transact SQL command is going to run in. And since we're running a DBCC statement, the database consistency checker statement, it doesn't matter what database you're in because this is ran at the SQL level. So we'll just go ahead and choose shrink database here and pass in the database AdventureWorks. There we go. And that's it. Now we can also go ahead and you can parse this if you'd like to, and that'll just check the syntax to make sure the command is okay. That's pretty much it. We have a simple step defined here to attempt to shrink the database and shrink all of its associated files. That's what this statement does. Shrinks the database files back to a manageable size. It'll also truncate the transaction log for us. And then also we have our advanced section here, and the advanced section just has some options here. You can define what a success action does. If this step succeeds, do you want to just continue to the next step? Do you want to quit the job and report success because this was a very important step, the only one that mattered? Do you want to quit the job and report failure for whatever reason? You can specify some retry attempts here. And also on a failure action, what would you want to do? You want to quit the job reporting failure, go to the next step, quit the job reporting success. Of course, we'll leave this as quit the job reporting failure if this step fails. And then also, since we're using transact SQL here, and even if you're not, if transact SQL is used in anything, then you can specify an output file because DBCC, for instance, it returns results. It returns such as the current size of the database, the minimum size, and just information about the results from that DBCC command. So you can specify a file here if you want to output that data to the file and just some information about that file. You can also choose to run this step as a different user if you're doing things that need higher access. So that's it though. Once you're done defining your step, we just choose OK, and boom, now we have a step in here. With, of course, its options as well, the type, on success, on failure. And that's it. From this point, you can add more steps in here. And again, they'll get executed sequentially. You can edit steps. You can insert steps if you have multiple ones here. Insert a step inside of one of these. You can also delete it. So you can also choose your start step down here. The next thing you can do is also define a schedule. And this is kind of cool. As I mentioned before, schedules are now their own objects. You can associate one schedule with more than others. And you can see that here by the pick button here. This will have a list of all the schedules you have in SQL Server Agent. We don't have any set up here, so there are none listed. And I'm not going to create a schedule since we're going to fire this job only if an alert takes place. But I'm going to show you here just how you create a schedule. You just click on New, and then you give your schedule a name, and then a type. If it's recurring, start this automatically when SQL Server Agent starts. You can see this is what we were talking about earlier. Start whenever the CPU becomes idle. I showed you how to set the actual conditions of when the CPU is idle. Recurring or one time. If it's recurring, this is where you define your frequency, your daily frequency. If you have multiple days you want this job to run on, so you're just basically automating this job for the times that it runs on, the frequency that it runs on, and the duration that it will run for between dates. But that's it. Once you set up your schedule or you have a schedule, you can associate that schedule with this job. And it's pretty simple. You can also create alerts straight from this. And if you have any alerts that kick off jobs, they'll be listed in here. Once we go ahead and tie that alert to this job, it'll automatically show up in here, which we'll do shortly. You can also create alerts right from here. As you can see, we can just, boom, create an alert right on the fly through this interface. Pretty slick. And also, here's the notifications tab. Actions to perform when the job completes. Of course, we want to, send an email here. We want to send an email to our SQL admin only when the job fails. And we also want to go ahead and we'll send a net send to our SQL admin only when the job fails. And you can do other things here, right to the Windows application event log when the job fails, automatically delete the job and such. But notification tab for the job itself. And then this targets, we'll talk about this here also at the end here briefly when I talk about how to deal and work with jobs in a multi-server environment if you want to run jobs on multiple SQL servers. But for now, to keep it simple here, there's our job. We have it created called Shrink Database. Once we click OK, it's going to go ahead and create that job for us. And now if we go ahead and expand our jobs folder, check it out. Shrink Database, there it is. So now one more thing we have to do here is go back into our alert just by double clicking on it, and then go back into the response tab here. And rather than notify an operator, we are going to execute a job. And all we have to do is click on the build button here. We'll go ahead and browse for our job. There it is, Shrink Database, the only job we have. We click OK here, we click OK here, and boom. Now our alert is set up to respond when it gets kicked off by executing a job rather than notifying an operator. And of course, if this job fails, then it will notify us. So pretty cool. Also, since we have our alert set up here, you can go into the history and check it out. It'll show you the date the last alert, when it happened, the date of the last response, the number of times this alert has happened, and you can also reset this count once it starts counting after it happens. But that's pretty much it. We click OK. Now our alert is set up, our job is set up, and our operator is ready to receive notifications. So we're ready to test this whole process out. Now how this is going to work, I created a little script that's going to fill up the transaction log in our AdventureWorks database to 100%. Once that happens, our alert is going to kick off, which will trigger our job. Once our job fires, our job is going to fail, at which point our operator will get a net send and an email notification. So I designed it that way so we could see this whole process work and all of our efforts come to fruition here. Now let's go ahead and do this. The first thing we're going to do though is go up to our AdventureWorks database. I'm going to go to the properties of this. And in the files, here's our transaction log. I'm going to turn auto growth off so we can get that transaction log to 100% here for demonstration purposes. Once we do that, I'm going to go ahead and open up a query that I put together here. Open file, open up our alerts here, choose to connect to our AdventureWorks database here. Now, again, this counter or this script here just creates a counter and then it loops through 10,000 times using that counter. Basically, we're inserting 10,000 records into our bug testing.testers table in a matter of seconds. So that'll fill up a transaction log really quick. So I'm going to hit execute here, and as soon as that's running, while that's running, I should say, let me just explain why this job is going to fail. Now, this job is going to fail because the dbcc shrink database command, first of all, cannot be run on a database that has a transaction log that is 100% full. It does try to truncate the transaction log, but again, 100% full, it can't. And also, it also couldn't anyway because these are all active transactions. So ideally, what you would want to do in this scenario is back up your transaction log. Have a job that backs up your transaction log. If that was the case, then everything would be fine. And check it out. Here we go. The job failed. We got our net send here. Shrink database was run. The job failed. Just tells what it was invoked by, so on and so forth. There's our message from our messenger service. Our net send worked. We click OK. If we go into our email here and do a send receive, see if we got anything. Hey, check that out. There's our email. Shrink database was run. 001 second. It failed. The job failed, so on and so forth. So our process worked. Our automation worked here. Our alert got kicked off, fired out the job. The job failed, which notified our operator, which was us, of course, of the failure of the job. Now, one other thing I want to show you here is the job activity monitor, and this is a really cool thing. If you double click on this, this will probably look familiar to you if you're familiar with previous versions of SQL Server. Basically what this is, it just lists all of our jobs, their current statuses, and this icon here represents the last run outcome, which is this guy right here, the last run outcome, which was failed. Of course, we only have one job here, SQL Server agent right now, so it's the only one to show. But this is again, just all the current status, what category it's in, the next time it's scheduled to run the last run. Again, current status, if it's idle or running or what have you, enabled. So this is, again, the only view we had in the previous versions of SQL when it came to jobs. And you can even manage these jobs from this interface. You can right-click on it, start the job, stop it if it's already running, disable it, enable it, and then you can view the history, delete it, view the properties, and edit it right here. So it's a nice little, just a nice little current snapshot of all of our jobs and how they look at this point in time. Another thing I want to mention here is something about multi-server jobs. Now, say we have a common job out there that could be run on all of our other database servers on the network. Say we have 5 servers out there that could all use this job. Rather than scripting this job out and running it on all 5 of those servers, and then of course anytime we made an update to this job, we'd have to redo that whole process, which is a manual process. We can automate it. What you can do is create what's called a multi-server job, in which case we designate what's called a master server, which holds the master copy of our job, and a bunch of target servers. Our target servers would then pull the master server to get that job whenever there's an update to it, or just download the job at regular intervals. And that's very easy to do. You just right-click on SQL Server Agent, go to Multi-Server Administration. You then make this a master server, and this will fire open just a little tiny wizard, very simple to use. You just basically choose your master server and your target server, and then you create what's called a master server operator, which will be the operator that can manage and receive notifications for all of the jobs across the network. So just wanted to point that out to you. They're very simple to set up and run, not much to it at all. That's why I'm not going to walk through it. Try it out on your own. Easy to do. All right, so in the CBT Nugget, we took a look at automating tasks with SQL Server Agent. We started off with an introduction to automation. I got you familiar with all the SQL Server automation components, how they interact with one another, and also got you familiar with the new database mail component. And then we took a look at how to configure automation. We looked at how to configure SQL Server Agent, both up from the service perspective and from the properties itself inside of SQL Server Management Studio there. And we also took a look at how to configure and set up database mail. Brand new, very easy to use mail engine, built from the ground up in SQL Server 2005. You'll have fun with that. I have fun with that. And I'm just so happy that it's easy to use this time around. Woohoo! And then we took a look at how to create operators, create alerts, and create jobs. We watched how they all interact with one another. We did a nice little demo there. Saw it all use the database mail, the net sends, and it all worked out great. So I hope this has been informative for you, and I thank you for viewing.